All right, here we go again. Again, I feel like these videos are optional because some of you by this point probably really know what you're doing and you can, move on with your life. If you are still working on it, that's great. Just keep going. I'm going to keep doing them and you'll have an answer key if you want to take a look at that. So I see two curves here, so I'm going to label them as 1 and 2, I guess. And curve number 1, I recognize immediately as cosine of theta over 2. So that was in another video that I may have mentioned was kind of optional. So that one I already know, and I'm just going to write it down. So x equals y equals, so this is for number 1. So the origin was shifted to -4, 4. And then I know that it's actually just cosine of theta over 2. So I'm going to say plus cosine theta over 2, and then cosine theta, and then plus cosine theta over 2, and sine of theta. So that one, you're not really required to know cosine of theta over 2, but it's kind of like a neat thing. I bet my video is like, my face is right in the way of that, and I should have thought about that. Oh, actually, I can move that. Let me move it down a little bit, just in case. I should probably watch more of the videos so that I'm aware of what's actually happening, but who has time for all that? All right, so let's see. Now we got to do this limicon. I'm thinking it's a positive cosine limicon with an inner loop, which means that the coefficient will be bigger than the constant. And I need to definitely know where the origin is to pull this off. So it should be through, it's where the inner loop starts and stops. And the reason that we need to know it is so that we can like work out our distances. All right, so positive cosine is going to start like way out. So I'm going to start here. And then I'm going to go to here. Whoa, I'm accidentally highlighting things. There. And then I don't actually know when I get to the origin, but I do know that this, stop highlighting things. I wish you could see what I'm complaining about. When I get to there, that's going to be at pi. So when I'm at pi, instead of going in the pi direction, so going in the direction of the negative x-axis, I go in the direction of the positive axis, so I know that r is actually negative when I get there. So let's fill in some values, and then we will write the equation. So our distance here, that's 8. That's -8, so that's 16. So then our distance here, that's 4, and that's -3. So this distance is 7. But I often count that wrong, so I'm going to check the other one too. So this is -3, and I go to -10, so that's also 7. So I'm pretty confident. And what I'm going to do is I'm going to make my table of values. And then from the table of values, I'll probably make the rectangular graph and then go from there. Theta and r. So when theta is 0, r is 16. When theta is pi over 2, r is 7. When theta is pi, what are we getting? So the origin was shifted to -8, and the distance from that to the outer part of the inner loop to that point that I indicated at -6, -3. So that distance right there is 2. So I'm going to say -2 though, because we're going, I'm tempted to say in the wrong direction, but we're going not toward pi, we're going away from it. And 3 pi over 2 is going to be back at 7, and then 2 pi would take us back to 16. So if we turn this into a rectangular graph, we need to do 7, 16, -2. It's kind of amazing how this just keeps working out. I mean, it's going to, because that's the premise, but it's so useful that we keep getting to use things we know. It's my favorite part about analysis, I think, is that it just like stacks up. You're not wasting your time when you put in all that effort to learn something, because it's going to show up again. All right, so this is definitely 7 plus 9 cosine, which kind of conforms to what I was thinking. So I'm going to say r is 7 plus 9 cosine of theta. And then the origin was shifted, so our shift, to where the inner loop starts and stops. So to there, so -8, -3. All right, let's write our equation. So it's going to be, I think this might be my favorite color that I can use in this app. It's either this or this. I like them both. They're subtle. I think that's what I like about them. But anyway, delete that one and then keep going with this one. So x is, y is, so we got -8 and then -3 and what else? So we're going to go plus the quantity 7 plus 9 cosine theta, and then there'll be a cosine of theta because we're writing it parametric, and then plus the quantity 7 plus 9 cosine theta, and then sine theta. There you go. So I'm actually going to take, let me see what the next problem looks like. Okay, this one I think is not so bad. I'm going to just jump in and do it. We've run into this first curve several times. This one's going to be kind of interesting. But anyway, let's deal with number one, right? So number one, I'm just going to go for it. X is, oh, and then I'm going to have to move this down. Y is, so actually maybe I'll end up doing this on 2 pages. Let me move it now. Okay, so I can see that the center was shifted to -4, 4. Not very creative, that keeps coming up. So the radius is going to be 4. I see 1, 2, 3, 4. I see 7 petals. It's sine because there's nothing on the x-axis. So did I already do this one? It feels like I did. So I'm going to do plus 4 sine of 7 theta, and then a cosine of theta, and then plus 4 sine of 7 theta and sine theta. Okay, and that's done. So now what I want to do is I want to deal with this graph, and this graph has a lot going on. It's a circle, so it doesn't look like it has a lot going on. So actually, let me copy and then paste so that we can deal with this in like an open setting. All right, so if the center, so I'm going to do a lot of like polary things here, right? So if the center, there are 5 potential centers. You could have the middle, you could have here, you could have here, here, you could have here. Sometimes it freaks out and thinks I'm trying to select things. That's why I went, Okay. So there are 5 potential centers, and each of them has a different polar curve associated with it. So what I'm going to do is just kind of summarize that instead of writing all of them, right? So I'm going to do center and then polar curve, and then you could write the equations. I'm fairly confident. So if the center is here, then the polar curve will be this. We're going to make a table. Okay, so if the center is 6, -3, which is the actual middle, then that's just a circle that has a radius of 2. So then the polar curve is actually just r equals 2. And that's probably the one that most people would go with. But what if the center was 8, -3? Well, if the center is 8, -3, then you're dealing with a circle that is centered on the negative x-axis, and it has a diameter of 4, so it's going to be r equals -4 cosine theta. So this is combining a lot of the things that we already know, but they're all in there. So what if our center was actually -1, 6? Okay, if it's -1/6, then this is a circle that is centered on the negative. So maybe if I draw it, let me draw it over here. If it would be like this. So that's going to be a circle on the negative y-axis with a diameter of 4. So r equals -4 sine theta. I like that there are so many ways to write this. It's like it's really interesting to me that that's a possibility. So what if the center is 4, -3? I didn't even make my table big enough. So 4, -3, you're dealing with this. That is definitely not how that's drawn, though. It's drawn like this. So it's on the positive x-axis, diameter is 4. So it's going to be r equals 4 cosine. And then finally, what if the center is, what is that? -5. What? 6, -5. That was really hard. Is one of these wrong? 6, -3, 8, -3, -1, -1. X is 6, y is -1. Yeah, that's wrong. That felt wrong. Here, let me clean that up. Okay, so that would be if the center was at 6, -1. 6, -1. All right, that feels better. All right, and then the other one so I knew that one of them was wrong because there was that like random x coordinate claiming to be part of the center. Like there's no way that was going to work. All right, so here I'm at 6, -5. 6, -5. Okay, so 6, -5 is going to be this one. So it's on the positive y-axis. So it's going to be r equals 4 sine of theta. And all right, so I'm going to stop there for this one. I'll be back to maybe finish the rest of these. Who knows? But definitely back for more. So I'll see you then.